All right. So with the complex number operations, the very first thing we're going to do is they're going to talk about something being in complex form. And when they talk about that, that's A plus BI form. And for that one, basically, here's what it means: that the A is the real number part, and then the BI part with the I term, that's the imaginary number part. So, but they're basically breaking this up into two things. You got a real number part, an imaginary number part. Real number part goes first, imaginary part goes second. Okay, so what that means is if you have an answer that is negative 3i plus 12, now, and the answer is actually okay if you write it like that, but if they tell you to put it in A plus BI form, you just have to take this answer and write the 12 first, and then the negative 3i would go second. It's not a big deal. It's just a little thing. In Math Excel, probably both of these answers would be okay. But if they talk about complex form, they just want the real number first, the imaginary part second. Um, Again, not a huge deal, but it's just one little thing that they'll talk about for this one. Okay, so we're going to do three operations. We're going to do add, subtract, and multiply for these. When you add or subtract complex numbers, it's really not any different than anything else we've been doing so far this year. That as we're going through these things, you'd still treat the I just like any other variable. So you can, as far as adding and subtracting goes, you can pretend that the I variable is like an X variable when it comes off of it. Okay, so really what that means is when you do this, that whether you're adding or subtracting, you just need to combine like terms. Okay, so first example we'll look at. What do you want with addition? Because addition, there's really not much that you've got to worry about with addition. So you got 3 plus 2i and then plus negative 6 plus 5i. Okay, and usually they'll put parentheses around it like this. Just know this is the first complex number we're looking at, and we're going to add that to this next complex number. And for these, all you have to do with addition is basically, there's not much to this that you're going to have that's different. You're going to take the real number here and then add it or subtract it, whatever the signs tell you to do with this number here. So that is 3 minus 6, which is just negative 3. And then we'll do the same thing with imaginary numbers. You're going to have a positive 2i and a positive 5i. So then you're going to do 2i plus 5i, which is just going to make that out to be a positive 7i. And that's the answer that you're looking for. Okay. And again, with the combining like terms, anything that's just a number, it's a constant, you add those things together. Anything with the I variable, you add or subtract those two things together. And again, it all just depends on the signs that you have and what you do those. This was 3 minus 6. We actually subtracted those numbers. This was a positive 2 and a positive 5. So then we did 2 plus 5 to make that 7i. And remember, you always take the sign that's in front of the number. So this plus always goes with the 2. That plus always goes with the 5. That minus always goes with the 6. The 3 didn't have a sign, so it basically just means there's an understood positive that would be there as you go through that. Okay, so adding, not really anything you have to do that's weird for this one. With subtraction, it's not hard. You just have to be careful. Okay, so for subtraction, we're going to do 4 minus 5i minus 6 minus 9i. All right, again, here's the part, again, to just, it's not hard. Just be careful. Don't get in a hurry as you go through this one. Because what you've got to do with subtraction ones is the first number is okay. It's 4 minus 5i. That part will not change. On the second one, where you've got this minus here, that really means that's a negative 1 times 6 minus 9i. Which basically means if you've got a minus in front, it's almost like distributive property with a negative 1, that it's negative 1 times 6 and it's negative 1 times negative 9. The negative in front means you've got to change both signs. That means this is going to be a negative 6, which most people get. It's always the second one that people forget to change. That's going to make that a positive. No. So anytime you see the negative in front of the parentheses, you got to change both signs. This was a positive 6. Now it's a negative 6. That was a negative 9. Now it's a positive 9. And now you're going to do just like we did before. Now you're just going to combine your like terms. Now you got a 4 and a negative 6. So that's 4 minus 6. If we do 4 minus 6, that's negative 2. All right. Then we've got a negative 5i and a positive 9i. So if we do, and if we go backwards order, if we do 9 minus 5, that would make that a positive 4. And that's the answer that we're looking for there. All right, so again, subtraction is not hard. Just be careful because almost everybody will get this sign correct, where I'm going to lose, on the test, I'm going to lose 4 or 5 people, maybe 2 or 3. That they're going to forget to change this second sign back here, and they're going to miss this problem just because of that one sign here. So they'll get the first one correct. It's always the second one that people forget to change that sign that's there. All right, I'm going to give you one more subtraction one just to make sure we got it. Everybody good there? Everybody still need that one? All right, one more subtraction. Okay. Okay, so again, first one doesn't change. With the minus in front of the second parentheses. Again, what we're going to do is we're going to change that negative. So it's a minus negative. You're going to make that a plus 5. And because of the minus sign here, that's going to change that one from a positive to a negative. Okay, so that's the only thing you've got to be careful with subtraction is, again, if you've got the minus sign here, that means you've got to change both signs before you can start adding and subtracting. Okay, and then once you do that, and I almost like circling these sometimes, you've got a negative 7 and a positive 5, so that's negative 7 plus 5. So that would be a negative 2. Okay, for your I terms, you've got a positive 3 and a negative 4, so that's a positive 3i minus 4i. So that's 3 minus 4, that's negative 1i for that answer there. Okay, now, and the 1's optional in this case, because if it's like, again, it's like x, you don't have to put 1x. So we could do negative 2 minus I, and that answer would also be okay. Now, if you put the 1i, that's fine. If you don't put the 1 with the I, that's fine. So either one of those two answers will be okay if you go through that. Because again, the I variable is just like an x, just like you don't have to put 1x on it. Same thing for this one. You don't have to put the 1i. If you just leave it as negative I, that's okay. All right, so for multiplying, now this may be part that you may have forgotten these, so maybe kind of doing some things with this one. It's either distributed property or doing the full method. And if you do or don't remember, the full method is just a double distributed property. It's where you do the distributed property twice as you go through these. Okay, and just like with addition and subtraction, you treat I like any other variable. And here's the unless part. Spell here. Unless you get I squared. And if you get I squared, this is what we're going back to yesterday. You replace the I squared with -1. Okay, so it's either distributed property where you have to do, distributed property one time. Full method, which is again, it's double distributed property. So it's either one of those two things. And again, everything works the same. The only thing you do different is when you get I squared, which you probably will in all these multiplication problems, you take out the I squared, you replace it with -1. And then after that, you just add, subtract, whatever it says you got to do with your like terms as you go through this one. So it starts with multiplication and then turns into an addition or subtraction problem because of the steps we've got to take after we go through that. Okay, so the first problem, we'll do 6i times 2 minus 3i. Okay, so for this one, it's just distributed property. So all we're going to do is we're going to take the 6i, multiply it times 2, and then multiply it times 3i. So if we do 6i times 2, that's going to be 12i. If you do 6i times -3i, that's going to be -18. If you do or don't remember, when you do a variable times itself, when you do I times I, that's going to make it I squared. Just like if you did x times x, it would be x squared. If you do I times I, it's going to be I squared. So for that one, really just one thing you have to do. So now that we've got the I squared here, you're going to take out I squared and replace it with -1. Okay, so it makes it 12i. If you do -18 times -1, that just makes it a positive 18. Okay, and again, that's a good answer, but they're probably going to ask for you to write the answer in a plus bi form. So then we're going to take this answer in an a plus bi form would be 18 plus 12i. Okay, and again, with multiplication, every single problem should have an I squared in it somewhere because now they may give you one little random one where it's not, but pretty much every problem you should have an I times an I to get I squared in there somewhere that you got to work through. Okay, so the next one we'll do the full method, which again, some people just call it double distributed property. So we'll show you that one. So if it's 2 minus 3i, we're going to multiply that times 4 plus I. Okay, so first thing we'll do 2 times 4, and then 2 times the I, so 2 times 4 is 8. 2 times I is just 2i. On the bottom side, negative 3i times 4, and then negative 3i times I. So negative 3 times 4 is negative 12i. And again, technically that's a 1i, so it's negative 3 times 1 for negative 3. And again, if you do I times I, that will make it I squared.
Can you go over how you get the FOIL again?
Okay, so basically it's just double distributed property. So we're going to take everything over here and multiply it by 3. And then we're going to take everything over here and then multiply it by 2. So it's 2 times 4 and then 2 times I to get this part. And then do the negative 3 times the 4 and then negative 3 times the I. Yeah, some people call it FOIL method. Some people call it double distributed property. As long as you know what you're doing, it's basically, again, it's really just double distributed property. Some problems they may actually make you do like a triple distributed property where you got 3 terms. But basically, you're just taking everything and multiplying it by itself, or all the different numbers. So it's 2 times 4 and 2 times the I, negative 3 times the 4, and then negative 3 times the I. Okay, and for all the problems like this where you set up and you do the FOIL method, it should always be the same thing. The first number is good. It's 8. There's not really anything you can do with that part. The 2 terms in the middle, though, they have the I term. So this is basically the adding, subtracting. It's 2 minus 12. You can make that negative 10. And then the last one, when you do the I times the I, you get the I squared. So we're going to take out the I squared and replace it with negative 1. So it's negative 3 times negative 1, which will make that a positive 3. Okay, and then one last step. Now you got, if this I term wasn't in the middle, if that was gone, you would just have 8 plus 3. So now we can do the 8 plus 3 and then just make that 11. So we've got 8 plus 3 and then minus the 10i. So then we can do 8 plus 3 to make it 11. Okay, and again, we'll do one more of the FOIL method just so we can see it here. But it's always the same things. You should have 4 numbers when you get finished. The last one, if it's I times I, you'll get the I squared. The 2 in the middle, you should always be able to add them or subtract them. This one, you'll make it after you do the negative 1 substitution, you get a number, and then you just add or subtract those numbers together to get what you're looking for. Okay, last one of the day. We'll do one more multiplication, and that'll wrap us up. So for this one, we'll do 6 plus 5i and then 6 minus 5i. Okay, so again, with the FOIL method, double distributed property, we're going to forget the 5i for just a minute. We're just going to do 6 times both of these. So we're going to do 6 times 6 and then 6 times 5. So for 6 times 6 is 36. 6 times negative 5i is a negative 30i. All right, and then we multiply everything by 6. Now we're going to multiply everything by the 5i part. So then we've got 5i times 6, which is 30i. And then 5 times negative 5 would be negative 25. And again, the part that most people forget, if you do I times I, it does make it I squared. Okay, so again, it should have 4 numbers. And again, it should always kind of be the exact same thing. The first of your 4 terms you got here is just a number. It doesn't change. It's 36. When you do the negative 30, positive 30 in this case, that one, and sometimes this will happen. You've got negative 30 plus 30, or it's 30 minus 30. That will actually go to 0. If it goes to 0i, 0 times anything is just 0. So that's just a 0 in the middle. And you can put plus 0, you can put minus 0, whatever you want to put there. And then for the I squared, again, take out that, make it negative 1. So it's negative 25 times negative 1. That makes it a positive 25. So we've got 36 plus 0, which is just 36, and then 36 plus 25 would just be 61. Okay, so when you're doing these, the answer may not always be like this, where you've got a real number and imaginary. Sometimes you get just a number. Sometimes it may be that if you're doing these, you may just get like the negative 10i for the answer, if you go through these. So the final answer can look a bunch of different ways. Just realize that the first two steps that's here, basically everything up to this point always looks the same. That you'll have some number, you've got some I term you've got here, and you'll have some number at the end. It just depends on how they set up that. Sometimes, again, the I term can go away, or it may be that the whole number goes away, or the real number, and you're left with just the imaginary number.